Good morning and welcome to another reaction video here on the Angry Astronaut. Starting to enjoy these, but one thing that I have never done is a reaction video to an article. But not that long ago, Boeing came out with an advertisement about Starliner, actually on spacenews.com, where they are lauding the accomplishments of the Boeing Corporation and talking about what Starliner is going to represent for the future of spaceflight. And so it shouldn't come as a surprise to any of you that I wanted to react to this. And if you think that I've started to go soft on Boeing, well, you're going to find out the truth in just a moment. Now, real quick before I get started, if I could ask a favor of you guys, one of the things that I always get asked by people who don't really pay much attention to spaceflight is, why are we doing this? Why is it important? What can it really do for us? And why spend all this money? Well, one of the biggest reasons, in my opinion, is space-based solar power, something that can provide the ultimate in green energy for the planet. It can provide 4 times as much energy as a traditional solar farm of the same size, even more when we're talking about wind. It's just one of the best ways to deliver green energy to the planet. I actually got to interview the scientist who's in charge of this particular project here in the UK, and they also, of course, she's involved with the European Space Agency as well, and it's called the Cassiopeia Project. Very fascinating, and this isn't just something that they're theoretically working on. This is something that they are going to be building very soon, at least a proof of concept in orbit. They've got the funding from European governments to do it. Really exciting. She's unbelievably knowledgeable, obviously, about the topic, and you are missing out if you don't watch this, so check it out. It is linked at the end of this video. Let's get going with Boeing. So, by the way, this is my first time reading this, at least in depth. I've kind of, skimmed it in the past, but I'd like to just kind of check it out with you all. One day after launching May 19th from Florida's Space Coast on a United Launch Alliance Atlas V rocket, the CST-100 Starliner spacecraft docked to the International Space Station, signifying a historic moment for the program. Yeah, you finally got it to where it was supposed to go. Given the fact that you already tried it at the end of 2019, when I first started this channel, by the way, that was their first attempt, and they've been failing ever since, but they finally managed to do it. That moment was the first step toward next carrying astronauts to and from the space station, which will expand Starliner's reach to low Earth orbit and shape the future of commercial human spaceflight. Obviously, it's not going to shape the future of human spaceflight because Crew Dragon has already done that. And Starliner is always going to be about 50% more expensive than Crew Dragon, number one, because of the development cost, and number two, because of the rockets that have to haul it to orbit. They are more expensive than Falcon 9 because they're not reusable. Even Vulcan is never going to be as inexpensive as Falcon 9. Vulcan has advantages, of course, in terms of its fairing size, etc., but this will never shape the future of human spaceflight. So let's see here. Starliner mission director Leroy Kane had a front row seat. The deputy program manager and director of the program integration for Boeing's Commercial Crew Program was on console at the Mission Control Center in Houston after watching the 6:54 p.m. Eastern Standard Time launch in person a day earlier at Cape Canaveral Space Force Center. It was really exhilarating to watch, said Kane, who previously worked at NASA for 28 years and directed 20 space shuttle missions. And it was pretty neat to have our team see U.S. astronauts floating around in our vehicle. Well, yeah, I'm sure it was exciting to finally see that. So, the next time Starliner flies, experienced naval aviators and test pilots Barry Butch Wilmore and Sunita Williams will be on board as commander and pilot, respectively. They will be the first of many to fly to and from low Earth orbit destinations, including the ISS, aboard Starliner. And of course, what they don't mention is the fact that the previous individual who's supposed to be commanding this mission, Chris Ferguson, excused himself from the mission in October of 2020, citing personal reasons. That's the only reason he gave. And astronauts never turn down a chance to go back into space. But for some reason, this very experienced astronaut, who, by the way, was regarded as the best choice to head up the next the first Starliner crewed mission, for some reason withdrew from the program. And we can get into why in a little bit. So, Boeing's technological advances for future space applications. Starliner is part of Boeing's Space and Launch Division, which has a role in building the world's largest rockets, small satellites, in-space habitats, and everything in between. Engineers have spent years developing innovative technologies that today, for example, set Starliner apart from other vehicles. Boy, I want to hear that. One of the most notable and unique innovations is Starliner's fully autonomous universal navigation system called the Vision-Based Electro-Optical Sensor Tracking Assembly. It acts as the eyes of the spacecraft, determining the location and orientation of the vehicle relative to the stars around it. Vesta, as it's called, was born out of a partnership between Boeing's Laser and Electro-Optical Systems, or LEOS, and Phantom Works, which originally used the technology to acquire, track, and defeat drones. Its first use in space was during the Orbital Express satellite repair mission in 2007. Although Vesta is fully autonomous, pilots have the capability to engage and maneuver the spacecraft at any time. What sets Vesta apart is that it not only can dock Starliner with a fully prepared and welcoming space station, it can also find and lock in with a host of other, possibly less mature destinations in space. This capability gives Starliner many options when choosing future space destinations under numerous mission scenarios. Okay, well, as we have seen, Crew Dragon can do all of that as well. It's demonstrated that it can dock with the space station autonomously once again. But one thing Starliner theoretically might have an advantage on is the fact that it has more traditional piloting control systems. So that I have to give it to them. Dragon has much more in terms of just point and click, not really traditional pilot control. So it's a lot more reliant on that. That could theoretically be an issue. Starliner's cameras, sensors, and computers work together to see the area around the spacecraft and autonomously steer it to the docking port. Okay, blah, blah, blah. Computers aboard Starliner time precise thruster firings to move the spacecraft carefully along a path to rendezvous with the target, line up at the docking port, and then gently make contact and complete the connection. It may sound easy. Well, no, it actually wasn't easy for anybody who watched this, but all of it is done as both Starliner and ISS are moving above the Earth at 17,500 miles per hour. The sensors on Starliner carefully measure the speed as the two spacecraft come near each other, blah, blah, blah. So in any event, yeah, all of this works great in theory, and Crew Dragon, as we have seen, can do this as well. But Starliner had a number of issues during its last test with even trying to do this. It had a number of thruster failures throughout the entire process. Almost every part of the propulsion system on Starliner experienced some kind of failure. Now, granted, its redundancy systems worked out just fine, and it was eventually able to dock with ISS, but it wasn't quick and it wasn't easy, and they still seem to be having problems with their propulsion system. I still don't think it's a great idea to be putting astronauts on this thing, given that it still had so many glitches during its last mission. Granted, way fewer glitches than it did the first time around in 2019, but still far from flawless. Okay, the next two innovations were demonstrated during the physical connection of Starliner and the ISS. During the last few meters of approach and through what's called hard dock, it was showtime for the Boeing-developed NASA docking system, or NDS, and the International Docking Adapter, also made by Boeing. Essentially, there are two connections the docking systems need to make to complete complete the connection. First, 3 latches on Starliner's extended docking ring need to snap closed as soon as Starliner's docking hatch touches the docking adapter of ISS. Those 3 latches will be the only things holding the 2 spacecraft together for the next several minutes to allow shock absorbers to smooth out any leftover energy from the docking process. Yeah, all of this sounds very good, but once again, it didn't work smoothly. The whole system had to be rebooted during this docking process in order for the docking to even be attempted. Starliner sat out there for a considerable period of time before they finally managed to get the damn thing to work. However, it did eventually function, and it did do its job as designed. The 2 were developed by Boeing under a NASA contract to meet the international space community's desire for a universal docking system that could be used by any spacecraft to connect to any other orbit and in any other mission. So maybe this thing theoretically has a more universal type docking system that might work with other types of space stations. I don't know. I have a feeling that anybody who designs a space station in the future is going to make it compatible with Crew Dragon, given the level of success that it's had up to this point. But, in theory, maybe that is indeed the case. So anyway, they definitely emphasize or talk about that a great deal. While in flight and when returning, Starliner also uses solar energy to help power the spacecraft. Well, yeah, like just about any spacecraft. The solar cells, which are located at the bottom of the spacecraft service module, are built by Spectrolab, a Boeing company and the world's largest manufacturer of spacecraft solar cells. The cells work by capturing different portions of the energy spectrum to convert solar energy into more than 2,900 watts. Their systems recorded steady electrical production even when the solar... Another unique aspect of Starliner is its ability to land on land rather than water. That is a big advantage. I'm not going to take anything away from Starliner in that regard. Its ability to land on the ground, water recovery is a complicated and expensive thing. If you can bring your spacecraft down on land instead of water, it does make a big difference. And by the way, this is one of the huge advantages of Dream Chaser and something that will reduce its costs over time. If you don't have to do a water recovery, Dream Chaser can land on a wide variety of airfields across the planet, just like the shuttle. That being the case, it is far less expensive to retrieve Dream Chaser than it is either Crew Dragon or Starliner for that matter. But yes, ability to set down on dry land is a big advantage. There's no question about that. And it has a parachute and airbag system which is designed to absorb shock impacts. That's why it can set down on land. Once again, that's definitely a good feature. For its second orbital flight test, Starliner autonomously undocked from the ISS following 6 days in space. After re-entering the atmosphere around 30,000 feet above the ground, Starliner jettisoned the forward heat shield that protected the parachutes during re-entry. 2 drogue parachutes began slowing Starliner down, etc., etc. We know about that process before it set down at White Sands. And back at Mission Control in Houston and the Boeing Mission Control Center at Kennedy Space Center, everyone, controllers, engineers, and leadership, went to the floor to celebrate. I don't blame them. Given all the problems this thing had during that flight and all the other problems that it had prior to this, they should have gone down to celebrate. Okay, so Boeing in space. On the Starliner front, Boeing is refurbishing 2 capsules for upcoming flights. The first for the crew flight test in February 2023, coming up really soon, and the second for a long-duration crew rotation mission to the International Space Station. The crew flight test will demonstrate many of the same objectives as the successful Orbital Flight Test 2. Well, kind of successful. It did have a number of problems, this time with 2 experienced naval aviators and test pilots on board. They'll be monitoring the spacecraft systems, performing manual flight operations of the autonomous vehicle, and monitoring the performance of Starliner's automated environmental propulsion and guidance systems. They will also perform manual actions to ensure that the backup flight control systems function as designed. Once again, I kind of like that, the fact that, it works kind of like the space shuttle in terms of your ability to cut in with manual control. That seems to be a little better than Crew Dragon, assuming that it actually works properly. And finally, they will assess the spacecraft environment for comfort, including temperature, humidity, and acoustics, all part of certifying Starliner for long-duration crew rotation missions to and from the International Space Station. Starliner's future includes providing crew and cargo transport to Orbital Reef, the commercially developed, owned, and operated space station that, when constructed, will operate as a mixed-use business park in low Earth orbit. Meanwhile, a contract extension was awarded to Boeing Space and Launch in 2020, some time ago, to continue to support the International Space Station through September of 2024. Not a whole lot of time. Just by way of comparison, Crew Dragon has been awarded contracts all the way through the scheduled retirement of the ISS in 2030. The number of flights that have been reserved for Starliner are precious few, actually. If we're talking through September 2024, that's actually not very many flights, considering that they're only supposed to be flying once per year. Also, the Orbital Reef thing. That is nonsense. I really don't think that Starliner is going to be doing too many flights to Orbital Reef, and here's why. Dream Chaser is going to be a human-rated spacecraft way before Orbital Reef is even operational. Dream Chaser is substantially less expensive to operate, and here's why. First of all, it can land on any runway, and that makes it less expensive to deploy than Starliner is. Its development costs have been lower because all of it's come from the private sector. None of it has really come from the government, so that also makes a big difference. And as I say, they haven't spent as much money as Boeing has spent on it. Therefore, they don't need to recoup as many losses. But most importantly, Starliner has Shooting Star, a module that can be attached to it to carry a substantial amount of cargo and also to carry out secondary missions, even when it's in its crew configuration. That being the case, then you can reduce the cost to passengers if you have secondary missions in your cargo capsule, or it's an independently functioning spacecraft, not really a cargo capsule. So if you have that added on to your crew unit, that being the case, you can reduce the overall cost by a substantial amount. Starliner is always going to be the most expensive game in town, and therefore nobody's going to be interested in riding it unless there's some really huge reason that they have a close relationship with Boeing or something like that. This is a spacecraft with no future. And here's something else that Boeing regards as a feather in their cap. They seem to be sort of delusional about this. Boeing also builds the core stage for NASA's Space Launch System, or SLS, and will build the rocket's upper stage for future missions. SLS is a foundational piece of the Artemis program that will return humans to the moon for the first time since the Apollo program. Right now, I wouldn't be bragging about SLS at all. It's a project that continues to cost NASA an insane amount of money. It is so far past overdue right now. Well, we all know what the problems with SLS are. And to make that a big part of your advertising campaign, I would wait until it's actually made a successful flight before I start saying anything about SLS right now. Because at the moment, SLS is just a big negative. And probably one of the saddest things about this advertisement is an interview I just read with Steve James, who's the Boeing's deputy chief engineer of the Starliner program, who's led the development of the propulsion power systems and such for the spacecraft. And when he watched Starliner dock for the first time during OFT2, he got goosebumps, it says. Well, I think he probably had goosebumps and was probably breaking out into a cold sweat, given all of the problems that spacecraft encountered before it docked. Thruster failures, problems with the docking system. It took an entire day of troubleshooting before they finally managed to get this thing to dock with ISS. And honestly, I think he's also going to be breaking out into a cold sweat when this thing has human beings on board. And let me tell you something. I can't tell you how I know this, but I know that some people who are involved in this first mission are terrified. They're very, very frightened about the prospects of these astronauts on board simply because, not because of anything that hasn't been revealed about the spacecraft, but because of the problems that it's experienced. Keep in mind, those thrusters, sure, the failures, the redundancy system worked out just fine. But if something goes even more wrong with the propulsion system on the next mission, especially during re-entry, the astronauts are in terrible trouble. If you don't have the necessary maneuvering thrusters during a re-entry, if you don't have what you need, you're either going to come in too steep and burn up, or you're going to come up too shallow, skip off the atmosphere, and go crazily out into space, and eventually re-enter and burn up at some other point. Either way is not very pleasant. And the fact that they did encounter problems with the propulsion system on numerous occasions, well, multiple occasions anyway, during this flight, it's got to be a scary thing indeed. So in any event, it goes on to quote him saying, "When I came to Starliner in 2011, we were still working with clean sheet designs, putting together the architecture of the vehicle. We went and flew and did things the right way, putting safety first and making sure we didn't rush. And look at the results. It was one of the highlights of my professional career." Not sure how he could say that with a straight face, because look at the results. 2019, when I started my channel, was the first time that they did an unmanned flight test. And we all know how that went. They almost lost the vehicle on 2 different occasions, and then NASA implemented no less than 80 corrective actions that they had to undertake. And even after all of that was done, all of those stuck valves during their next attempt to try to get it into orbit again failed. And even during this so-called successful mission, there were still multiple problems during the entire process. Now, granted, Dragon had some issues as well, but nothing like this. Nothing like this. The fact that your propulsion system is still having hiccups right now, that should be a big warning sign indeed. So, in any event, he also says, in this business, the highs are pretty high and the lows are pretty low. Well, that's certainly true. It's not for everybody, but having done this for 35 years, I can say that human spaceflight kind of gets into your blood. Those of us who do it love the business. We believe in it. We feel strongly about the mission. We're passionate, and we're in it to win it. Let me tell you something, Boeing. You've already lost. You really have. Crew Dragon has already demonstrated that it can do everything that Starliners that can do, and can do it for less money. And frankly, I think they can do it more safely as well. Boeing is already woefully over budget on this project, and it's a fixed price contract, which means they can't just keep charging NASA more money for the amount that they run in the red. This program is always going to be in the red for the rest of its existence. And how do you make up for that? How do you make up for a program that continues to run your company further into negative numbers as you make every launch attempt? It's just not going to work out properly. And as a result, the only place where you can save money to make the losses for your company less severe is to cut corners. Cut corners, especially in regards to safety. And that's what's happening here, because this last mission that they had was not good enough, in my opinion, not solid enough to risk astronauts on the next mission. And I'm not the only one who thinks that. And that's all I'm going to say, by the way, about that particular issue. But that being the case, Starliner is not a vehicle that is going to represent anything innovative, anything game-changing for the future of human spaceflight. It is instead, at best, a vehicle that will fly maybe half a dozen times to ISS, and that will be the end of it. No commercial enterprise will have an interest in flying Starliner in the future, given that both Dream Chaser and Crew Dragon will be able to offer the same kinds of services for less. And if you're talking about, setting down on land, greater convenience, whatever, Dream Chaser is going to have it beat hands down in so many regards, being able to land on a conventional runway instead of in the middle of nowhere in white sands, and also just the sheer cost of launching Starliner on top of a Vulcan Centaur, presumably in the future, something like that, is going to be substantially more expensive than launching on top of a Falcon 9. The only place where you can make up for the cost differences between Vulcan and a Falcon 9 is if you can carry out other missions, secondary missions, which Dream Chaser can with the Shooting Star module. It can be extremely competitive because of that additional feature, which Crew Dragon, by the way, doesn't have. Crew Dragon cannot carry tons of cargo and passengers at the same time. Dream Chaser can, and it's going to be a very competitive vehicle indeed, whereas Starliner is going to be left in the dust. And by the way, that's at best. At best, that's what it's going to be able to do. At worst, we could be encountering a vehicle that leads to astronauts' deaths for the first time since the loss of Columbia, which, by the way, also involved the Boeing Corporation. Please like, please subscribe. Again, please check out that interview that I had with the British Space Agency, the UK Space Agency, about solar power. That's a huge one. And check the description for various ways to support my content. And as always, stay angry about space.